Okay, Jay. Welcome to another past paper session. This is November 25 for 2. This is an M1 exam. Let's start solving the first question in kinematics. Let's see. It says the diagram shows the displacement time graph for the motion particle. This of a particle, the particle starts from rest at a point A and travels with a constant acceleration of A, taking 4 seconds to move a distance of x. The particle then returns to O with a constant speed of 40 over a period of 2 seconds. Okay, so the gradient here is 40. Find the value of x and the value of a. So this is 4 comma x. This is 6 comma 0. So I can find out the value of x. That's easy. Change. So gradient is minus 40 in this case, minus 40. So y2 minus y1 or x2 minus x1. So x is then 80. Okay, that was easy. Find the value of a. What is a? And travels with a constant acceleration a, taking 4 seconds to move a distance of x meters. So how can I calculate a in this case? Uh, so for acceleration, the particle must have reached that speed. So I can say that during this process, the speed increased from 0 to 40. It started from rest. So the speed increased from 0 to 40. That means that the change in speed over the change in time is acceleration. So that's 40 over 10, 4 meter per second squared. Okay, a railway locomotive of mass 240,000 kgs is towing a coach of mass 36,000 kgs down a hill inclined at an angle of this. So sine theta equals to 0.04. The driving force produced by the locomotive is 450,000 and there are resistances to motions of 12,000 on the locomotive and this. The coupling between the locomotive and the coach is light, rigid and parallel to the hill. Okay. So a railway locomotive is towing a coach. So that's 240k. The coach is 36k. I'm going to write that like that. And what is happening is the driving force produced by this is now it's going down the hill. It says down the hill. Okay, 450,000, and the resistances to the motion 120,000 on the locomotive and 15,000 on this. There's obviously tension in the coupling between the light, rigid, and parallel to the. Find the acceleration of the locomotive and the tension in the coupling. Okay, so for locomotive, what is happening is that 450,000 and gravity is driving it. What is gravity? The gravitational force. So 240, 2400k sine theta. So I'm going to write 2400,000 sine theta is 0.04. Okay. Those two things are driving the locomotive. So, and what is resisting it? What is resisting it? There's 120,000 in the resistance, and then there's tension in the resistance as well. So 240,000 A, F equals to MA basically. Okay. For coach, what is driving it? Tension is driving it. So yeah. Okay, and its weight is also driving it. So 360,000 into 0.04. Okay, 36,000, basically mg sine theta. And then what is resisting it? 15,000 is resisting it, equals to ma. Okay, I think then I can just do a simultaneous thing and see what all of these add up together to be. So 450,000 is the driving force, and then 2400,000 into 0.04 minus 120,000, and then plus 360,000 to 0.04 minus 15,000. So this is giving me 425,400. And what do I have on the other side? 240,000 plus 36,000. 276,000. 425,400 divided by. I'm getting a very different sort of number. I will check if that is the correct answer. Yes, that is the correct answer for A, 1.54 meter per second square. I was only confused because the numbers are very complicated. I wasn't sure if calculator part was correct. There's tension as well that I need to calculate. So I'm going to say that T plus 360,000.04 minus 15,000. What I would recommend is that on this question, you do some individual calculations and write them down. Not doing them sort of put me on the edge of whether I was doing this correctly or not. Okay, I'm calculating the tension now. Coming out as 5,607. So I don't really need to round that off. That is also fine. 560. Okay, because I have taken this has to be rounded off. Why? Because I have taken a decimal number up there. So 56,100 newtons. That should be the correct answer. You would also get marks for getting 56076. Okay, there's a mark for that. Okay. Okay, so question number three says the car of mass 1400 kgs travels on a straight horizontal road, accelerates uniformly. So acceleration is constant. That means I can use the constant acceleration formulas. Use 15 v is 20, and the distance is 175. Find the time taken. So half u plus v times t. And use this formula. That's easy. So t is 10. There's a constant resistance force of 800 newtons to the motion of the car. Use an energy method throughout to find the average power of the car's engine as the speed increases from 15 to 20. Okay, so work done by driving force is change in K plus change in B plus work done by resistance. So the easiest thing is work done by resistance 800 into 175. The car is going on a horizontal road, so P is 0. Change in K half M V square minus U square. Okay. Now I don't have the work done by the driving force, so I'm going to let it stay as it is. It's not 0. There's a power of the engine that's working. I don't know that power. I cannot take I have to show you the average power only. So I'm just first going to calculate this, and then I'm going to show you the next working. So 20 square minus 15 square into 1400 divided by 2 plus 800 into 175. Okay. So work done by driving force is 262,500. Now, if you remember the power formula, it's power equals to work done upon time. So 262,500 divided by the time that I got from the previous answer. So divide by 10. So 26250 watts. Okay. So then it says find the steady speed. So an acceleration 0 that the car could maintain on the horizontal ground if the engine is working at this um, power found in part. So if the power is 26250, if I divide it by velocity, that's the driving force. The resistance is 800 throughout equals to ma. The acceleration has to be 0. Okay, steady speed means acceleration has to be 0. So 1400 into, oh, sorry, 800, 26250 divided by 800, basically. So what am I getting? V is 32.8125 meter per second. Okay, let's check again. That is the correct answer. Yes, that is indeed the correct answer. It's exact, so I'm going to leave it like that. Question number 4 quickly. A particle of mass 0.1 kg is projected vertically upwards with speed of 30 from horizontal ground at the same instant. At the same instant, a particle q of mass 0.4 kg is vertically projected upwards with speed 10 from a height of 115 meters above the ground. Sorry, my bad. Move that up. Okay, so this distance is 15 meters. P and Q move in the same vertical line. Find the height above the ground at which P and Q collide. Okay, so acceleration has to be minus 10, acceleration has to be minus. Okay, this will cover a distance of x, and this will cover a distance of x minus 50, basically. Okay, because if they want to collide, they have to be at the same height, right? Or I can say this is plus 15 and this is going to be easier that way. Okay, the time is going to be the same because they were projected together. So S equals to ut plus half at square, and S equals to ut plus half at square. So I can replace x with 10t minus 5t square. So 20t equals to 0.75. I want to find the height. So 10 into 0.75 above the ground. Above the ground. So I'm going to have to add 15 to it. Okay. So 10 into, this is a very typical question. 4.6875. Height above ground is x plus 15. 19.875. Okay, that was easy. When P and Q collide, they coalesce. Find the speed of the combined particle at the instant when it reaches the ground. Okay, so what were their speeds when they collided? That's important for me. Speeds before collision. Speeds before collision for P. Q was 30, A was minus 10, T was 0.75. U was 10, A was minus 10, and T was 0.75. Okay, so V equals to U plus AT. So I'm assuming it's still going up. Okay. So what were the masses then? The masses were zero point 0.1 and zero point 0.4. So before equals to after, zero point 0.1 into 22.5 plus zero point 0.4 into 2.5. Now they've coalesced, so zero point 0.5 into V. So V is coming out as 6.5. V is coming out as 6.5. I want to check if that is correct. Yes, that is correct. So what's going to happen now? They've coalesced. They're now one particle. They're still moving up. So I'm going to say that it's going to keep moving up. Okay. What do I have to find at the instant when it reaches the ground? Okay. I have to figure out what height. I've already figured that out. 19.875, 19.6875. So yeah. So what I'm going to say is that the acceleration is minus 10. Its displacement has to be minus 19.6875. Okay. And I want to find out the speed at which it does that. The particle is going to go up like that and then come down because it's coalesced into one particle. Okay. So v square u square plus 2as. So v square u square v square is 436. What's root of 436? 20.88, so 20.9 meter per second. Okay, that was the easy way of solving this question. Good, easy 5 marks, I think. Okay, look at the next one. A block of mass 5 kgs is being pulled down a by a force of magnitude 20 newtons. The plane is inclined at an angle of 10 degrees to the horizontal, and the 20 Newton force acts at an angle of 35 degrees above the line of greatest slope of the plane. The coefficient of friction between the block and the plane is zero point 0.4. Okay, so the coefficient of friction between the block and the plane is zero point 0.4. So 0.4 R, sorry, 0.4 R. Okay, let's draw R. Let's draw the weight as well. 50 sine theta, 50 cos theta. Okay, the speed of the block when it passes point O is 2 meter per second. Okay, let's resolve this force as well. 20 sine 35 and 20 cos 35. Okay, this theta is 10, so I'm just going to write 10. Okay, find the speed of the block when it has moved 3 meters down the plane from O. Okay, so I think I can do it with F equals to ma, or I can also choose to do an energy method. I'm just seeing if the energy method is there mentioned. Okay, so you can use an energy method as well. That's up to you. I will still have to find all the forces. It doesn't matter. Okay, but I think it's easier if I just say S equals to 3 and U equals to 2, and I figure out A first by F equals to ma, and then I find out V. Okay, so for F equals to ma, I am going to have to do driving force, so 20 cos 35 plus 50 sine 10 minus the resisting force, which is zero point 0.4 R, equals to ma. Okay, so how do I figure out R first? I'm going to say up forces equals to down forces. I think it's a very easy question unless I make a very silly mistake somewhere. I should get it right on the first go. 50 cos 10 minus 20 sine 35. R is coming out as 37.7. Okay, 37.77. Uh, that is my value for R. I will use that to find A. I'm going to multiply that by minus zero point 0.4 plus 50 sine 10 plus 20 cos 35 and divide by 5. So A is coming out as 1.9916. Okay, 9916. So U is 2, A is 1.996, S is 3. I want to figure out V. V square equals to U square plus 2. V square, 2 square, S is. So 3.99. Yes, that is the exact answer. Okay, that was easy, I think. Question 5. Okay, let's look at question number 6. This is a kinematics question. It is an 8-mark question, which means that I might have to do a significant amount of working to get to the final answer. I hope my mic is working. Yeah, okay. So a particle starts from rest at point O. The acceleration of the particle at time t seconds after leaving O is this. Find the distance that the particle travels from O until the time at which its acceleration is 0. So let's first find out the time. That's the easy part. So 1 over 2 equals to t plus 1 power minus half. You square both and you get 1 over 4 t plus 1 power minus 1. 1 over t plus 1 equals to 1 over 4. T equals to 3. Okay. So what do I do now? I start integrating. So V t plus 1 power half divided by half minus t plus c. So 4 t plus 1 power half minus t plus c. It starts from rest. It starts from rest. So c is coming out as minus 4. Interesting. Okay. And then what do I have to find out? I have to find out the distance. The particle travels from O until the time at which its acceleration is 0. Okay. So when is acceleration 0? It's at t equals to 3. But what I also should figure out is whether this particle is turning at some point during that motion. Why? Because it's going to be important for me, because if it turns, then I will have to split the distance. How do I find out if it's turning? I should do this. So t plus 4, squaring both sides, t square plus 8t plus 16. So t square plus 8t plus 16 equals to 16t plus 16. So t square minus 8t. So I'm pretty clear that the particle is not turning within that range where t equals to 3. So what I can simply do is I can integrate from 0 to 3 to find out the distance. What do I integrate? I integrate the vt function. So I get 4 t plus 1 power 3 over 2 divided by 3 over 2 minus t square over 2 minus 40, and I integrate from and I put limits 0 to 3. Okay, so 8 over 3, 4 power 3 over 2 minus 9 over 2 minus 12 minus 4 1 sorry 8 over 3, 1 power 3 over 2 minus 0 minus 0. Okay, let's do this on my calculator now because I think it's going to become tougher. That's 64 over 3 minus 9 over 2 minus 12 minus 8 over 3. I do typing mistakes. The answer that I am getting is 13 over 6. Yes, and that is the correct answer. Okay, so time consuming but easy question. Okay, let's move on to the last question for this paper. This is question number 7. It says two coplanar forces of this act at a point shown. In figure 7.1, the forces act in a vertical plane. The resultant of these forces has magnitude s newtons and acts at an angle of alpha degrees below the horizontal as shown in the diagram. Find the value of s and the value of alpha. That's part A. Okay. So I think that that's the easy part. I can say that this is s sine alpha and s cos alpha. So s cos alpha will basically be the horizontal resultant. How will I figure out the horizontal resultant? I'm going to say that this is 30 cos 30. This is 20. 20 cos 20. Just wait, okay. 15 cos 45. So the horizontal resultant is going to be 30 cos 30 plus 15 cos 45 minus 20 cos 20. 30 cos 30 plus 15 cos 45 minus 20 cos 20. So S cos alpha is coming out as 17.7935. S sine alpha is basically downward forces are heavy, so 25 plus 15 sine 45 minus 30 cos 30 and 20 sine 20 cos 20, 20 30 sine 30, sorry, 30 sine 30 and 20 sine 20. So 25 plus 15 sine 45 minus 30 sine 30 minus 20 sine 20. I'm getting 13.766. Okay. Okay, I can find out S and alpha very quickly by taking a substitution and saying that S is basically, from the first one, S is basically 17.7935 over cos alpha. So 17.7935 over cos alpha into sine alpha equals to 13.766. Okay, so tan alpha is all of that. I get 0.77365. Tan inverse of this gives me alpha is 37.7. And when I have alpha is 37.7, I can use that to find S. I can say that 17.7935 divided by cos of answer basically. So 22.5. Okay. Okay, those are the correct answers as well. Let's move on. It says a small ring of mass zero point 0.6 threaded on a rough horizontal wire. The four forces shown in the figure 7.1 act on the ring. Okay, and are in the same vertical plane as the wire. The ring starts from rest and takes 3 seconds to travel a distance of 2 meters along the wire. Find the coefficient of friction between the ring and the wire. Okay, so it's best to just draw this diagram again. Okay, so if those forces were acting collectively, can I say that the resultant of those forces will look something like this? So I'm going to say that the ring was being pulled down like that. Okay, I know that, but there was mass for the ring also involved, which was 6. There was a coefficient of friction R, and then there was a frictional force also involved. Okay, and this was alpha. Okay, so what is going to happen? It says the ring starts from rest and takes 3 seconds to travel a distance of 2 meters along the wire. So time is 3 ss2. Okay, can I find out acceleration? Okay, 3 square 9. So that's 4 over 9 is acceleration. Can I now say that S cos alpha minus the frictional force equals to MA, which is zero point 0.6 into 4 over 9. S cos alpha is simple. S cos alpha was right here, 17.7935. So I'm just going to use that. Okay. What about frictional force? Frictional force is mu into R. So coefficient of friction is what I'm trying to find. I then need to figure out R. So R is then just upward forces equals to downward forces. So S sine alpha. R is going to be, what is S sine alpha? S sine alpha is 13.766. So this is going to be 19.766. Okay. 17.7935 minus mu into 19.76. Okay, so 17.7935 minus 2.4 over 9. 0.887. I don't know if that's correct. Yes, that is indeed the correct answer. That's, I think, the end of this exam. Thank you for watching.